Hello and welcome to Team 22's senior project, the Woodward Incorporated Vacuum Oven. The members of this team are Drew Sigiersma, Seth Gibson, Dylan Howcroft, Michael Whittle, and Jordan Cooper. Now the purpose of this project is that Woodward Incorporated is in need of a vacuum oven in their manufacturing process. The oven that they currently use to dry acidic compounds off of nickel alloy parts is nearing end of life, and they wish to replace it with a vacuum oven that is able to fit the same parts. This new system was to be designed with respect to efficiency, reliability, and durability, i.e., not only should this new oven decrease the current operational cycle time, but it should also be easy to use and be operational for a long period of time. The top-level operation of this new oven was designed with this in mind. The oven is to run its cycles in one of two modes, with and without a vacuum pump pulling the atmosphere inside the oven down to 1 torr. The entire system must have an emergency kill switch and will be operated using an HMI device loaded with a clear and intuitive operational program. Above all, the oven must heat the enclosure to the target temperature within a reasonable amount of time, and all factors must be monitored by the system. The system is divided into 5 major components: the oven enclosure, the vacuum pump it's attached to, the heating element inside the enclosure, and the control box holding the PLC and the HMI. Standard operation of this system is pretty straightforward. The operator turns on the system and starts to preheat the oven. They set the target values, including temperature, pressure, bake time, and when the preheat temperature has been reached, they load the parts inside the oven and start the cycle. When a cycle starts, it reaches the set targets, i.e. the target temperature and pressure, or just the temperature if it's running a normal oven cycle. Once these are reached, the bake timer starts, maintaining these values until the time elapses. Once it ends, the indicator light comes on, the oven will safely repressurize, and the dry parts can be unloaded. To heat this enclosure, we use conductive heating, which is the best medium for heat transfer in a vacuum, at least in this scenario. The inner vacuum chamber is built to be airtight, based on pressure specifications. The outer chamber was built not only to hold heating insulation, but was also built to have a simple aesthetic to avoid distraction. Under the 120 volt input limitation the electrical components are placed under, the outputs will be controlled by 24 volt coil operated relays. A 15-pin D-type connection will be used for the PLC to operate the pump, and the solenoids and sensors exposed to the atmosphere inside the oven will be resistant to corrosive, high temperature, low pressure environments. And here we have an exploded view of the oven system in its entirety, including the outer and the inner portions of the oven, the heating plate, and the door. Due to issues with this heating pad design not reaching target temperatures in time, we've switched to a design with a single plate with 2 heating pads stuck to the underside for the best heat transfer with the least amount of warping. And here we have the current system as of the 17th of July. We're very close to finishing. We'll be continuing to build, test, and refine up to design day and beyond to deliver the best system we can. Thank you, and have a nice day.